I have a question for Michael, I guess. I was wondering what you do with Lavoisier's stuff. What do you do with this early chemistry? How do you engage in that? How do you
Yeah,
make the hydrogen?
Antoine, great question. So Antoine Lavoisier, fascinating character, a French aristocrat, all kinds of awards by King Louis the 18th for lighting. He developed lamps for Paris, so he lit up Paris at night. Big inheritance from his ancestors. So he's this wealthy guy. So I'll get to the science in a second, but I can't omit this part. French Revolution hits, and guess what? His head rolls in the guillotine in the 1780s. Unfortunate ending, but he is the one in the history of chemistry where if a ninth grader reads a chemistry book written before Lavoisier, any one of us, we wouldn't understand it. If you read a chemistry book written by Lavoisier afterwards, all of us, even a ninth grade chemistry student, would understand it. So all the syntax, all the symbols, all the sort of the language of chemistry was Lavoisier. So he's sort of the founder of modern chemistry. The one big thing he did was actually two big things: conservation of mass. So that was suspected, but he's proved as much as you can prove it. So that's a big thing. So chemists always had a sort of a inferiority complex relative to physicists, especially with Galileo and Newton, such titans. This is 100 years later. Lavoisier is 100 years later after Newton and Galileo, a little bit over. Chemists, maybe to this day, still have this inferiority complex. But the conservation of mass finally gave chemistry a mathematical foundation that they had been searching for. Mass before equals mass afterwards. You have an equation. So it was this great mathematical foundation that he gave to chemistry. The other thing was he overturned this awesome theory of fire called Phlogiston, which was the reigning theory of what fire is for 100 years. He's like, no, that makes no sense. And actually the kids who take quantum courses, by the way, the first experiment they do, it's about Phlogiston. We back it up. We actually say in the articles, like Phlogiston is the theory of fire. So on the first few days of a quantum course, if a kid walks into their mom and says, hey, I know what fire is, it's Phlogiston being released from burnable materials. I tell the mom, say, that's great. Have them believe that. Then 100 years later, a few weeks later in quantum courses, the kid does Lavoisier's experiments and realizes, tracking me, that if you burn something like steel wool or any metal, it doesn't lose mass.